Good morning, guys. Today we're going to solve something called a literal equation. A literal equation has numbers and variables in it, and we're going to solve it for a variable. Usually we have one variable and we solve for that variable. But these equations have lots of variables and we're going to solve for one variable. So today's date is September 29th. If you are hybrid B, then you're going to bring me these notes on Wednesday. Not Wednesday, because you won't be here on Thursday, and I'm going to check them in for you. And if you're hybrid A, hopefully you're taking them with me. If you are at home, then you'll bring them to me. So we are going to solve these equations. There's 8 of them, and we're going to solve them for the indicated variable. So in this first one, we want to solve for y. What that means then is we want to get y by itself. So we're going to start on the side of y. So what's on the side of y? 8x is on the side of y. So in order to get rid of that, we're going to subtract it from both sides. Because it was positive, I'm going to subtract it. Because these are additive inverses, they're inverses, they cancel out. Okay? And then you're left with y. And on this side, because you can't combine them because they're not like terms, you have 12 minus 8x. And that's your answer. You just got y by itself. Some take 1 step, some take 2 steps. So that's a literal equation because we literally solved it for a variable. We don't have anything else, that's our answer. Okay, so we're going to do number 2 now. In number 2, we're also going to solve for y. But notice this time there's something in front of y and there's a subtraction sign. So we have more than one step. So just like the one that we just did, we need to get rid of the 7x. So I'm going to subtract the 7x from both sides. These cancel out. I'm going to bring down the negative 3y, the equal sign, and then I can't do anything with the 7 and the 12 because they're not like terms. Remember, like terms have the same variables and the same exponents. Now I need to get y by itself. We're always keeping our eye on the variable we're solving for. So if this, let's say this wasn't there, how would we do that? We normally would divide by negative 3, so we're going to divide by negative 3. We're just going to divide everything by negative 3. Negative 3y divided by negative 3y, these cancel out, and I'm left with y. 12 divided by negative 3 is negative 4. Negative 7 divided by negative 3, well, we can't do that, but a negative and a negative make a positive, so we're just going to write 7/3 x, and that's our answer. Okay? So again, I'm just focusing on what I'm trying to do. And I'm solving it just like I normally would solve a regular equation. I'm getting rid of this, and then I'm dividing. Okay, so that's a 2-step equation. I got rid of the 7. The only thing is I can't combine everything. Okay, so let's look at number 3. Number 3, it says c equals 2 pi r. Well, notice that and we're going to solve it for r. Do you notice that the 2, the pi, and the r, there's no additions, no subtraction? That means that's because it's all multiplication. So in order for us to get rid of it, what we're going to do, I'm just going to rewrite this problem here. Since there's no addition or subtraction, it means it's all multiplication. The inverse is what of multiplication? The inverse is division. So I can divide by everything that's not r. And everything that's not r is the 2 pi. And I'm going to put 2 pi over here. C divided by 2 pi is just, oops, let's not do it like that. C over 2 pi. These 2's cancel out. This pi cancels out. And I'm left with r. Okay? So again, you have to ask yourself, is there any adding or subtracting? Because if there's adding and subtracting, then that changes things a bit. Okay, the next one I have is ax minus b equals c. Okay, what am I solving for? I'm solving for x. That means I need to look at where my x is. Well, my x is next to the a, so I'm going to leave that, but that b is there. And what is going on with that b? That b is being subtracted. So what is the inverse of subtracting? Now remember, you guys, when you solve these, you're solving them just like a normal equation. You're just moving everything around. So we're gonna, instead of subtracting b, in order to get rid of it, we're going to add b. Those cancel out because they're additive inverses, and you're left with ax equals, well, you have c plus b. Well, guess what, you guys? You can't add them because they're not like terms. So you just leave them. I know it's just like lots of letters, and you're like, oh my gosh, but always remember, you're trying to get x, in this problem, you're trying to get x by itself, so we're concentrating on that. Now, since a is in front of x, we're going to divide everything by a. So x equals c over a plus b over a. And leave it like that. That's perfect. Now, this one is different than this one because we divided by 2 pi, so we just leave 2 pi underneath the 1. So again, I got rid of the b first because that was being added or subtracting. Remember, it goes along the same way as it did. You're getting rid of anything that's being added or subtracted first. Okay? So let's look at number 5. Again, we're going to start with our adding and subtracting. Okay, look at this one, you guys. We need to solve for w. So I'm just going to rewrite it again. Now, we just need to be concentrated on what's being added or subtracted to the w. Added and subtracted. The 2 right there is being multiplied. This is being added or subtracted. And it's positive. So I want to get rid of the 2L first. So I'm going to subtract that from both sides. These are additive inverses. And I'm left with P minus 2L equals 2W. Always you're adding and subtracting. Now, you guys, let's say this wasn't here. Let's say this was a number. What would you do with the 2W? You would divide by 2 to get W by itself. So we're going to do the same thing. We're going to divide by 2. I'm sorry about this, you guys. W equals P over 2. And look, you guys, minus, and then look, these 2 cancels out, so you're left with L. Again, always starting with your adding and subtracting. So I subtracted 2L from both sides because that was being added. And I subtracted because the inverse of addition is subtraction. And then I divided by the 2 because that's what you would do. In a normal situation, you would just divide by 2. Okay. Let's look at number 6. A equals LW, and we're dividing by L. Is there any addition or subtraction? No, there's not. So what do 2 letters next to each other mean? Letters next to each other mean multiplication. So the inverse of multiplication is division. So what letter do I want to get by itself? I want to get the L by itself, so I'm going to divide by W. So A over W equals L. That's what we call a one-step literal equation because it took us 1 step to get the variable by itself. Okay. You guys ready for the next one? Remember, you can always pause me and go back. Okay, number 7. Here we go. Number 7. Again, you guys, it's another formula. What variable do I want to get by itself? It looks like h, so I want to get this by itself. So v equals pi r squared h. So the first question I'm going to ask you is, are there any addition or subtraction? Is anything being added or subtracted? Or do you see any addition signs or subtraction signs? No. Okay, so that means this is all multiplication. Guys, remember, when you see letters next to each other, it means multiplication. So what do I want to get by myself? I want to get the h by itself. So that means I can get rid of the pi and the r squared. So I'm going to divide by pi r squared. I can do this because there's no adding or subtracting. So v over pi r squared is literally v over pi r squared equals, and you guys can't see that. There we go. Let's just zoom in a little bit. This pi cancels out, this r squared cancels out, and I'm left with h. That's my answer. Okay, last one, you guys, last one. D equals RT, and we're solving for R. So D equals RT. Are there any addition or subtraction signs? Are you adding or subtracting anything to the T? No. Oh, to the R, sorry, we're solving for R. So are you adding or subtracting anything to R? No. What is R and T doing? They're being multiplied. What is the inverse of multiplication? The inverse of multiplication is division. So I'm going to divide by the T because I want to solve for R. So my final answer is D over T equals R. So the reason I could, the reason I could just divide by T is because there was no adding or subtraction, okay? And example 6, again, this one is just like example 8. The reason that I could just divide by W was because there was no adding or subtracting. And example 4, I had to get rid of the B because the B was being subtracted. So notice now I have addition and subtraction, so I need to move the B over. I was trying to solve for x, so I got ax by itself. You guys, if this was 8, we would have divided by 8. It just happens to be a letter this time. You guys, number 3, 6, 7, and 8 are all those, there's no addition or subtraction, so you can just divide. So again, 3, 6, 7, and 8 are all ones with just division. All you have to do is divide. 1, 2, 4, and 5, you're going to have to add or subtract first and then divide. I know you can do it. Tomorrow I'll put another little example up for you so that you can practice, okay? Thanks, guys, and have a great day.